Okay, now let us solve some of the examples based on the Froben's method which we just now derived. So let us say this is the differential equation is given to you. To write down it is into standard form, which is y double dash minus 2 y dash plus 4x square plus 1 upon 4x square y equal to 0. And if you compare with y double dash plus p of x y dash plus q of x y equal to 0. So comparing with this, we get p of x is equal to minus 2 and q of x will be 1 plus 1 upon 4x square, because 4x square you can divide. So we can observe that this x is equal to 0 is the singular point of ODE 1. We call it this is as a equation 1. To get the regular singular point, you know that it is, we have to check what is the x into q of x, which is minus 2x, and x square into q of x will be x square plus 1 by 4. Both of them are analytic. At x is equal to 0. Therefore, what we can say is the regular singular point of ODE 1. Since it is a regular singular point, it has the, using the Froben's method, it says that it was always has one solution. To get the another solution, we have to see what is the roots of the identical equation. So the first task is to assume as a solution. So let us has, so since it is a regular singular point, so we can say it has, therefore it has a Froben's series solution of the form y is equal to summation n running from 0 to infinity a n x raised to n plus m. A n is not equal to 0 and m is belongs to R. So obviously what is the first task is to differentiate this 2 times. Therefore we can have y dash, which is the derivative of y, will gives you n plus m a n x raised to n plus m minus 1, and y double dash will be summation n running from 0 to infinity m plus n minus 1 a n x raised to m plus n minus 2. This is another thing, we substitute all these values y dash and y double dash into the equation 1. So putting these values in equation 1, we get 4x square summation n running from 0 to infinity. You can just see what was our equation 1 is this 4x square into y double dash. So that's why it is 4x square into y double dash is m plus n minus 1 a n x raised to m plus n minus 2 plus, sorry, it was minus minus 8x square. So it is minus 8x square into y dash, that is summation n running from 0 to infinity m plus n an x raised to m plus n minus 1, and the last term was plus 4x square plus 1 into summation n running from 0 to infinity an x raised to m plus n equal to 0. We can write down or rewrite this equation as this: summation n running from 0 to infinity 4 into m plus n minus 1 an x raised to m plus n, x square will multiply inside, minus 8 summation n running from 0 to infinity m plus n an x raised to m plus n plus 1. This x square is also multiply inside, so it is m plus n plus 1 plus summation n running from 0 to infinity. This 4x square is multiplied to this series and 1 is also multiplied to, so there are two separate terms will come here. So it is 4an x raised to m plus n plus 2 plus summation n running from 0 to infinity an x raised to m plus n equal to 0. Okay. Now I want that all the power which we have here should be same for x. All the powers of x should be same. So that's why here we have power m plus n plus 1. Here we have m plus n plus 2. So instead of starting this summation n running from 0, I want it should be m plus n. This should be m plus n. So instead of n, I am replacing n minus 1. So this summation starting with 0, now it will start with 1. Okay. So the first term is as it is, that I may write down summation n running from 0 to infinity 4 m plus n minus 1 an x raised to m plus n. This is this as it is. Now in the second term, that is minus summation n running from 1 to infinity. You see, this was start with n equal to 0. Now I am replacing into this n by n minus 1. So that's why this will be m plus n minus 1. So it is 8 into m plus n minus 1 an minus 1 x power m plus n. This is the things we got, plus here in this summation it will start with 0 and the power will be m plus n. So in that I am replacing n by n minus 2. So now the summation will start with n equal to 2, and hence we get summation n running from 2 to infinity 4 into, instead of an we have to replace n minus 2, so it is an minus 2 x power, instead of m plus n plus 2 will now have m plus n, and the last term is already having the term m plus n equal to 0. So now for this one and for this one, we'll write down the separate two terms, that is for n equal to 1 and for n equal to 2, and for this one I will write down for n equal to 1 term. Okay, so everything now, ultimately what I am trying to do is I want the summation should start with n equal to 2, because that is the things we have here. So I am just writing all the other terms here. So first of all, n equal to 0 for the first term which we have here. So that is 4 into m minus 1 a0 into x power m. That is the first term. N equal to 0 term will get this thing. Plus I will put n equal to 1 also. For n equal to 1, what is the term we'll have? 4 into m plus 1 into m a1 x raised to m plus 1 we can have here. So now the rest of the things will start with n equal summation n running from 2 to infinity. Okay, so that I will write down later on. Minus, now for this n is running from 1, so I need to write down equal to 1 term separately. So that's why it is 8 m plus 1 minus 1, so it is m a0 because it is n equal to 0, so it is 1 minus 1 a0 x power m plus summation start with n equal to 2 to infinitive, so that 2 to infinitive I'll write down separately. Here also summation start from 2 to infinitive, that also we can write down separately. Here it is start from 0 to infinitive, so I'm writing two steps for n equal to 0 and 1 separately. For a0 we have, for n equal to 0 we have a0 x power m plus a1 x power m plus 1 plus the rest of the term will have, which is having the summation start with now n equal to 2 to infinity for all of them. So for that I may write down 2 to infinity inside bracket 4 into m plus n m plus n minus 1, so it is 4 into m plus n minus 1, then it is minus into an, then it is minus 8 m plus n minus 1 into an minus 1, that is this term. See, here is also x power m plus n is there, here is also x power m plus n is there, so I just take it out, this x power m plus 1 outside. Here we will have 4 into an, so it is plus 4 into an minus 2, and here it is an, so plus an into x power m plus n equal to 0, plus all the other terms which we have here, it is there. So now here it is a power of x power m, here it is also power of x power, all this power of x power m and all having the coefficient as a0, so that I am taking out. So therefore we can have now is 4 into m minus 1, 4m into m minus 1 plus minus, it should be minus minus 8m minus 8m and plus 1, and all together with a0 x power m plus this term which is having the an term, so it is 4 into m plus 1 plus 1 a1 x raised to m plus 1, that is then c, plus this term, whole term which we have here. So I am just copying that, the same thing here. Okay. Now what we'll do, we'll compare the coefficient both sides. So comparing coefficients both sides. We get. So what is this actually? It is, I may calculate here. This will be 4m square minus 4m. If I multiply this 4m inside, minus 8m plus 1. Is it correct? Calculation we have did. Yes. 4m square minus it has to be plus, otherwise it cannot be having the problem. So we have, where we have did the mistake. See, this is 8m square.
Minus 8m a0 x raised to n plus 1 also.
So minus
8 a0 x raised to n plus 1.
Oh yes, yes, yes. N is running from 1. So that's why it is x raised to m plus 1 is there. So here we have made a mistake. This is x plus 1 is there. So પછી આપડા આ સ્ટેપ્સમાં મિસ્ટેક છે ને, so this should not be there. This minus 8 actually come here, minus 8m plus 1 is there. Okay, એટલે આ minus 8 નહીં આવે અહીંયા. So that's why it is 4m square minus 4m plus 1. So that's why it is 4m square minus 4m plus 1 into a0 equal to 0. But a0 is never be 0, so that's why it is 4m square minus 4m plus 1 equal to 0. Sorry. The second thing we have, this is equal to 0. That is 4m into m plus 1 a1 minus 8m a0 plus a1 equal to 0. So this is 8m a0 plus a1 is there. A1 is common nahi nikla, a0 also, a1 also. This a1 will come here. So we have this, the things. So we can have this as a thing. And the last one, it is this coefficient, that is whole this thing will become 0. So that's why we can have, it is 4 into m plus n minus 1 an minus 8 m plus n minus 1 into an minus 1 plus 4 an minus 2 plus an equal to 0. That you can have here. This is the things we can have. And what is this? This is what? This is the identical equation. So here the identical equation is 4m square minus 4m plus 1 equal to 0. And the roots of this identical equation are, you can see that m will be 1 by 2, 1 by 2, because this is nothing but the 2m minus 1 square, whole square. That's why it is m will be minus 1 by 2, minus 1 by 2. Sorry, plus 1 by 2, plus 1 by 2. And therefore this m1 minus m2, and both of them m1 and m2 are same, will be 0. Okay, so we need to calculate another linearly independent solution into this case that we have discussed in the previous theory portion. Here m1 minus m2 are 0, so I need to have what is the one solution. So for m1 will be 1 by 2, I need to calculate what will be the Frobenius solution for that. So in that we can just observe in this second equation, and we call it, this is the third recurrence relation. So from this equation 1, now we'll have the value of m1 or m, which is 1 by 2. Substitute here, let us see what we get. So it is that we get is 4 into 1 by 2, 1 by 2 plus 1, that is 3 by 2. So let us write down that is 4 into 1 by 2 into 3 by 2 into a1 minus 8m, that is 1 by 2. So it is minus 8 1 by 2 a0 plus a1 equal to 0. So if you can simplify this, 4 will get cancelled with this. So this will be 3a1 minus, this will be 4. So it is 4a1, sorry, a0 plus a1. So that means this will implies a1 equal to a0. So the value of a1 will be a0. And from this equation, that is this equation number 3, if you substitute m equal to 1 by 2 there, let us see what we get. It is 4 into 1 by 2 plus n, then 1 by 2, not m, n, 1 by 2 plus n minus 1, an minus 8, 1 by 2 plus n minus 1, an minus 1, plus 4 into an minus 2 plus an equal to 0. By rewriting this, what we get? Let us write that. So it is 4 into 2n plus 1 by 2. You can see that this is, if you take the LCM, we will have 2n plus 1 by 2. So that's why it is 2n plus 1 by 2. This is nothing but the 1 by 2 minus 1 by 2. So it is again 2n minus 1 by 2. So that's why it is 2n minus 1 by 2 an minus 8 into, this is also 2n minus 1 by 2. So it is 2n minus 1 by 2 an minus 1 plus 4 an minus 2 plus an equal to 0, that is as it is, that we have written as it is, this two term. So hence we can write down an together term, you can write down both this combined, and this 4 will get cancelled with this. Here you will have 4. So you can write down this an equal to, in the denominator we can observe that this is the term we have 2n plus 1, 2n minus 1 plus 1. This is the term in the denominator we have, and the numerator will get 4 will be common from both of them, and here it is 2n minus 1 an minus 1, which is of course plus sign because it's minus, and this will be of negative sign, minus an minus 2, and this equation will true for n running from 2, 3, 4 up to so on. Okay, so what will happen for n equal to 2? So for n equal to 2, if you have, you will have a2, which is 4 into 4 2s are 4 minus 1, that is 3a1 minus a0 upon, this is 2 5 and this will be 3 plus 1. So how much it is? It is a 4 plus 1, 5 plus 4 minus 1, 3. 15 plus 1, 16. Okay. And we know that A1 is equal to A0. So due to this is 2 into A0 into 4. So that's why it is 8 A0 by 16. And so it is A0 by 2. Okay. Next, what will happen for n equal to 3? So if I substitute n equal to 3, we will have A3. So it is 4 into 6, 5, because we need to substitute 3 now. So it is 5 A2. It is 5 A2 minus 2 minus 2 A0. And upon this value will become, that is, you have to substitute 3, 7 into 7 to the, see this see this is nothing but the 4n square minus 1 plus 1 is there. So it is actually 4n square. It is simple ways to represent this quantity is actually it is 4n square. So why we are calculating much? So it is 1, if you substitute 3 now, so 3, 9 to the 36. So 9 to the 36. So it is 36. And A2 we already calculated as A0 by 2. If you substitute that value here, and if you simplify, you will have it is A0 by 3 factorial. That you can check this calculation. Now for n equal to 4, you will have A4 will be A0 by 4 factorial. That also you can check by yourself. And so on. So it is easy to predict for any n. We have an will be A0 by n factorial. So hence the one solution, that is y, will be x power m summation n running from 0 to infinity an x raised to n can be written as x raised to 1 by 2 summation n running from 0 to infinity an, that an is nothing but the A0 by n factorial into x raised to n. And what is this A0 by n factorial? If I have A0 will be common out, okay, then this will be x power 1 by 2 into A0 summation x raised to n upon n factorial, n running from 0 to infinity. Then what will be this? Summation x raised to n upon n factorial. Yes, anyone? Therefore, y1 will be x power 1 by 2 A0 into, what is this value?
E raised to x.
E raised to x. So this is e raised to x. Okay. So this is the one solution, and we assume without loss of generality that A0 is 1. So therefore, we'll have the one solution will be x power minus 1 by 2 e power x. Now question is to calculate another linearly independent solution. As per the theory, it says that you can have y2 will be, so the to find another linearly independent solution, we have y2 which is v into y1, where this v dash which is 1 upon y1 square into e power integration minus p of x dx. This is the things we have, which we have discussed in the previous lecture. This is the formula to calculate the another linearly independent solution. So hence v dash we can have 1 upon y1 square e power minus p of x dx. We already have the value of y1 into the previous slide. The y1 is this x power 1 by 2 e power x and whole square is there into e power minus what is the value of p of x. Let us see what is p of x for our case. The p of x was minus 2. So that's why this is minus 2 dx. So this will gives you x power, so it is x power 1 by 2 into whole square, so it is x e power 2x into e power 2 dx. So it is also gives you 1 upon x e power 2x into e power 2x. So that's why it is 1 by x. This is v dash. So you will have v will be integration of 1 upon x dx, which gives you log x. So what will be the solution? Therefore y2, you know, it is v into y1. V we have log x. We already calculated y1, that is 1 by 2 e power x power 1 by 2 into e power x. So hence the general solution is y equal to c1 y1 plus c2 y2, which is c1 y1 is x power 1 by 2 e power x plus c2 log x into x power 1 by 2 into e power x. So this is the general solution for given differential equation we have. Let me give you one more example to solve yourself. I hope you will able to do this example by your own. So x square, solve this, y square y double dash minus 3xy dash plus 4x plus 4y equal to 0. I want that everyone should try for this example here.